Hey folks, welcome back to our video blog series on Haskellings. And this is going to be a really exciting week because we're going to really increase the effects of the watch mechanism, basically by chaining our exercises together. You can see in this module list for the first time we have multiple exercises. We have types 1 and we have types 2. So our goal here is to go from one exercise, and then when we complete it, we'll move on to the next exercise. And so we can just take a quick look. So exercise 2 just added a few more things about lists and tuples. Obviously, if you can look, this file isn't going to compile. And then we also have our original types 1 file. We've made a few changes to our utilities, just added a couple more functions here. Like we have a helper that tells us whether or not our file contains the sort of I am not done signal. So if you recall, in fact, I should actually open this file back up. So we can see we have I am not done at the top, so you can keep that in the file if you don't want to move on to the next exercise. But once you take it out, then we're going to want to move on. So I'll just should open those both back up. And then we also just have, we had the concept of exercise info. I don't know if you could have quickly seen that in the exercise list module, but we combine essentially the module name, its Haskell module name, the directory that we want, and then the file, all just into one tuple. And so this last helper function just creates the full file path given our project root and those different elements. So that's all we need from our utilities, but most of the action is actually going to happen in our watcher module. And we're going to need quite a few changes here. Our overarching concern is that we're going to write this run exercise watch function. And just like everything else, this is going to take our project root and our GHC path, but it's also going to take a list of these exercise infos. I'm just going to open up that file as we get one more look at that. This sort of tuple, which gives us, the name of the module, the directory that it lives in, and then just the Haskell file name, because we're going to be passing around this quite a bit. And we have a list of just all of our exercises in order. We also have our mapping that is updated for all of the exercises. So I say that because we're going to be passing that around a lot. And the run exercise watch is going to take this extra parameter of all of the uncompleted exercise infos, or at least, when we open it up, this will contain all of the exercises, but as we note which ones are complete, we're going to remove them from our list. And of course, it's going to be an IO action. And of course, the key thing we want to observe with our base case here is that, if there are no exercises left, then you're done. So we can just say, congratulations, you've completed all the exercises. But then more interesting case arises when, we have our different paths here. So paths, and we have basically our first exercise and then the rest of the exercises. And this is where the fun is, because this is where we take a look at this first exercise and determine, hey, is this done or not? Recall that we have returned the exit code now from our compile exercise function. So compile exercise now takes the full exercise info. So this will give us our exit code and tell us has this completed, does it compile, and we also want to know, has the user written, have they removed the I am not done designation. So we're actually going to use not and say, so file contains not done, and we actually want a full file path. We're going to use that helper as well down here. So we'll get the full file path for our exercise and just say, okay, is this current exercise that we're working on, is it done or not? Does it compile? Have we removed that line or not? Now, if it is, if both of these are true, so if exit code is a success, and is done. Then we can actually make a recursive call now. We can sort of cut off the first element of this list and just recurse on the rest of our list. So say run exercise watch, spelled, exercise watch, that's paths, and then we'll just say rest of the exercises. And that's sort of another base case where we're just moving on. Otherwise, what we want to do is we'll drop into a loop where we start doing a lot of what we're already doing in watch exercises. We're going to refactor this at the end, but we want to do a lot of this stuff down here. But first we want to check, okay, if it was success, if the exit code was success but we are not done, then we're just going to give them a quick message to say, hey, you can remove this message when you want to move on. So we do that with say when exit code success, exercise compiles, and you can just remove that from the file. So we just let them know, and then we drop into essentially the same loop. So we're going to create our configuration, and we're going to start watching the file for changes. So again, this message won't print if it doesn't compile. There we go. So we'll create our same configuration, and now we need to ask ourselves what needs to change about the way that we're using fs-notify, this library. And in particular, we might see that our file check can actually be a little bit different now. We don't want to just be checking for any arbitrary Haskell file that exists in our map. We're really looking for one individual file at this point. So we're going to give this an extra argument of exercise info. And we don't even really care. Yes, we still don't care about these other cases. And what we really care about is the file name. And yeah, we don't care if it's in the map. We don't care if it's a Haskell file. We're just going to say, okay, is the base name of this file the same? So we take the file that actually changed in the operation and then our exercise file and just compare them. We can compare the base name. And that's just going to be the only check we write. So instead of having should check file down here, we have to pass in the exercise info. And then our process event is also going to be a little bit different now because it also needs a few things. We'll start by giving the exercise info. And we can remove sort of this calculation on the module name because we're going to know the module name at this point. That's in the exercise info. We're going to get its directory and its file. And at this point, like we have the file already. We're just going to assume that our process event only gets called when it should, when the should check file function really deals with that. So we're actually just going to ignore the event itself. We're going to assume we already have the file. And we're going to take out, again, that map membership case check. We don't really care. So we're just going to go here. Oops. And we're going to start running the exercise straight away. And we'd also like to compile the exercise. And this time we're going to get the exit code. Because we want to evaluate the exit code so that we can say, okay, this has compiled, and we can pass that information back to our run exercise watch function and let it know. Basically let it know that a success has happened. So we're going to say, okay, case exit code of success. We also have the exit failure case. And if it fails, then it will automatically, the compile exercise function will automatically print the output we want to tell them. So we don't really need to do anything else here. I'll just say return that, essentially empty action. But when it comes to what do we do when it's a success case? Once again, we want to check is not done. And this is also going to require, similarly, that we take a look at what the full file path is. Except instead of project root, I think we just want first of config paths. And instead of first x, we just want exercise info. Okay, so that is essentially what we need to determine if it's done. And so, if it is not done, then again, we're going to print the same message that we had below. You can remove this exercise compiles, but you need to remove this line in order to move forward. Oops, that goes line below. Cool. And then that's all we have to do. Now, this else case is interesting because we have to determine, okay, how do we actually inform the run exercise watch function about what happened? And we might say, oh, we just like to return a value here. We like to say, okay, this is IO result. And this is a little bit of a problem for us because the API of FS Notify requires that this be IO unit. It requires us to not really have a return value. And so it's a little tricky. How do we actually relate this information, that we've succeeded? How do we relate it back to our original function? And I don't know, maybe there's a better way to do this, but I'm going to use, because we have multiple threads here. We have the process event is a different thread from our watcher thread. So basically, I'm going to create an MVar. And we don't really need any information in this MVar. We just need to know whether it is there or not. So this is going to, it's going to call this signal MVar. Which will signal to the process that calls us, or the thread that calls us, I should say, that we're done. And so at the end of this process, if we have succeeded, if we're done, then we're going to say, okay, put MVar, and we're just going to place this empty value into that MVar just to signal that we are done. So now let's go into our exercise watch function. What needs to change here in order to account for that? So we have our manager here, and so let's make the signal MVar. It's going to be new empty MVar. And now, for the first time, we are actually going to care about the return value of watch tree. What watch tree really returns is a stop action. Watch tree is an IO action that returns another IO action. And once we're done, we're done watching this particular tree, we can invoke it. We can say stop action, and it will stop watching this tree. But we want to block on that until we've gotten our value in our MVar. We don't need this thread delay. Instead, we're just going to say take MVar, signal MVar. So until our MVar gets filled, we're just going to sit tight, and this thread is going to stop. And then once we get that, it will stop. And so this condition needs to happen before we move on here. But once we're done with that, once this MVar is placed in there and we take it out and we're done, then we're done with this exercise. So we can then place our final recursive call here. And that's all lined up. So the last thing we need to do, obviously our original watch exercises function can change. Instead of doing this logic itself, what we're going to have is that, oops, didn't do that much. It's actually just going to invoke the function we just wrote. And I need to add a few more imports, like just import everything from exercise list. I think we missed system.exit. Control.monad we used when, I think maybe on this as well, not positive. But, and we also, we're just going to import everything from control.concurrent because we used a few more things there. So now let's go and check out how our code works. Go into our terminal. See if I made any mistakes here. Oh, okay. Oh, that's right. There were a few changes I forgot to make. Because down here, you know, we have our should check file. We account for should check file, but our process event function that gained a couple more parameters here. So we want to pass these, except I think we can just say paths instead. Also, we do use project root there. So we need to pass paths as the first, and then we say first x is our exercise information, and then we'll also pass the endpoint. Let's see if that works a little better. Okay, different number of arguments, and the last we have this other case of process event that also needs the additional arguments. Whoop, pattern match is redundant. Oh, that's right. Okay, we don't need that pattern anymore, because we're no longer matching on the event itself, so we can just take that out. Okay, and now we have our function, so let's take it for a spin and see how everything works. So we get to our first module. This is types 1, and obviously it does not compile. Let's go here. Do this like we've always been doing. And now it tells us that it's successfully compiled, and we should remove I am not done. Move this line. And now that compiles, and we've moved on to types 2. And we'll make these tuples match. So we'll say bool, int, and a string. And this should be a list of floats, not a list of ints. All right, and again, we have to remove I am not done. And there, now it says we've completed all the exercises. If we watch it again, it should say the same thing. So that is the implementation for our multi-exercise watcher. So yeah, in the coming weeks, we'll start making a few more modifications. Some topics I have in mind for what we can do are are essentially running unit tests within the executable rather than just checking for compilation results, and also just writing unit tests ourselves for this project. It's certainly going to be an interesting task, and it's going to require a lot of different rewriting of the mechanics of this program, but it's definitely working with a complicated interactive process like this is it's very challenging to write good unit tests for that. So that's definitely another topic we'll be exploring. But hopefully at a certain point, I'll just be able to put this on GitHub and just have people start adding exercises to it. And we'll see what comes out of that. So thanks for tuning in this week, and make sure to come back next Monday morning for our next video.